Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And we have a returning guest. And it's kind of been a theme here lately. I feel like if you've been doing this a good bit, like sometimes you get those really good guests and then you ask them back for updates and what's going on in the industry. And that's what we're going to do today. So for today, we have Adam Jacob, CEO and co-founder at System Initiative. And first of all, Adam, welcome to the show. And then I want to give a quick background of the last time we spoke.
Yeah, thanks. I'm pleased to be here.
Thank you. Thank you. And yeah, so we last spoke, I think mid 2023. And we were kind of talking about like DevOps 2.0, if you will. And for those that missed that show, tell everyone a little bit about your background. And then we'll kind of pull everything forward from there.
Yeah, so I suppose we'll go in chronological order. So like my career started as a systems administrator in the like middle 90s. And then from there, grew into doing automation. I wrote a thing called Chef, which became a successful configuration management tool and company. We eventually sold that company to Progress, which was delightful. And then I started System Initiative a couple of years later to basically reinvent the way we think about doing automation kind of broadly. So, through that time of sort of building automation, both myself for the systems I was managing, but then also for other people, I got the chance to go see, a ton of different companies from a bunch of different perspectives and help them figure out like, how are they going to use automation to sort of make their technology companies function? And what I kind of learned in that process, especially toward the end of Chef, was that for all of our good intentions, that no matter how smart the people I was working with were, the odds that they were going to be able to build automation that fulfilled their goals, they wanted to be able to deploy safely. They wanted to be able to do it on demand. They wanted to be able to do it in really complex enterprise environments, and they were just going to fail. And for no fault of their own. It just wasn't going to work. And, the sort of key insight was that it was because we were treating this domain of automation, this idea that we have to automate how our technology systems function. We were treating it as like a bespoke thing. We were just deciding that what we should do is like, write code that glues together all the different systems and makes them work, which works. It was reasonable enough that we got there. But in fact, it turns out that that's a thing that you can reason about as an activity in the same way that we, think about building like video games. When people build video games, they don't like fire up Vim and just start like writing a video game. I mean, they can, but they mostly don't, right? Mostly they go use an engine, right? And the engine has an idea of what it means to build a video game, and you program the engine. Or, if you build like Formula One race cars, they build simulators of sort of how the car would function so they can run the car more often. And System Initiative does that for automation. So it understands like, what does it mean to model something that you want to automate? And how do we see what that is? And how do we interact with it in a simulation to know what we want to see? How do we do it sort of in real time together? And then how do we apply that to the real world, or have the real world update our conception of what the automation should be or should be doing?
Yeah, no. And so first of all, shout out for mentioning Vim. And also
Thanks.
Probably all the Emacs users out there just got, rage quit the podcast on that.
I mean, they're welcome. I like that too.
I'm a Vim person, by the way. I'm a Vim person.
Yeah,
anyway,
I'm just not.
So
my favorite people are Emacs people.
So let me let's talk about this, right? So the last time we talked, we spoke about, DevOps 2.0, right? And so
Sure.
like there's DevOps 2.0 and then there's infrastructure as code. And like, where are we at on like that journey, right? Like what's in our topic today, by the way, is like moving on from infrastructure as code.
Yeah.
And so like, what's broken about infrastructure as code? Like tell everyone about what's going on, first of all.
Yeah. I mean, so first we have to start with just like, if we didn't have infrastructure as code, like the world is better because we have infrastructure as code. So like, let's just let that be true, because it is. And if you've ever managed a large environment using infrastructure as code, it sucks. And the reason that it sucks is because it's kind of a mismatch for what the actual environment is that we're trying to automate. So for example, when you like decide to write an infrastructure declaration in like Terraform or Pulumi, right? What you're doing is saying, this is how I want the infrastructure to be. It has one state and one state only, which is, I don't know, running probably is roughly the state that you want it to be in. But actual infrastructure doesn't work that way at all, right? If you think about, something as simple as like an EC2 instance or a DigitalOcean droplet, like if we just think about the states, how many are there? It could be on, it could be off, it could be running, it could be rebooting, it could be terminating, it could be, right? Like we could do that multiplied by every possible thing that we interact with. And so you wind up with this abstraction that tells you, hey, if you just give me this declaration, the system will sort out how to make it work the way you want it to, except when it doesn't. And the exceptions cause no end of problems. And then thinking about how we then correlate that information and then use it somewhere else becomes kind of impossible. So like, right, if you're building a system to do application deployment and you're going to build it outside of your infrastructure as code, but the infrastructure as code in theory has all the data about like what you should be talking to, but there's no easy way to get it, right? Like what would you do? Crack open the state file and they tell you very explicitly not to do that. So like it becomes this sort of weird information silo that gets kind of locked up in the code. And so a lot of the problems that we see in how we can build and maintain these really complex automation projects, they stem from the fact that rather than thinking about it as a data problem, as a modeling problem, we think about it as a programming problem. And that's not to say we shouldn't be programming the system. We should. But what we should be programming is the model, not the actual code that does stuff. And it's a subtle distinction, but it starts to enable you to do stuff like I built a demo the other day where we added vSphere support in a very simple way to System Initiative. And so what you could do was discover the running VMs, and then we wrote another function that knows how to take those discovered VMs and translate them to the appropriately sized EC2 instances in the cloud. And if you think about how to do that, it's just really hard to imagine how to write that. And it was like,
Sure.
It was like 100 lines of JavaScript because the model sort of supported you in doing it. And so, yeah, infrastructure as code, it gets us a long way down the road, but especially at scale, there's some technical problems with it. And then that's without talking about the human parts, where when we think about how we interact, we know that what brings about good outcomes in DevOps is how often do humans interact? How much do we talk to each other? How close do we get? The way we collaborate, you can't hear my air quotes, but hear the air quotes that I put around collaborate, is through pull requests. We literally do some work on our own. We send that code up. We then ask someone else to review it. Mostly what they do is tell us what we did wrong, hopefully, if they read it at all, or they just sort of rubber stamp it because they weren't paying attention. And then we just go back and forth. And if you've ever tried to do that, for a complex infrastructure as code project, like you might have a very long PR where you're just going back and forth about, well, what's the state of the actual system? And did things drift? And will this destroy the wrong thing? And like, there's a ton of human pieces there that really go wrong. And then you ask a developer to do it and it's even worse. And so this is why infrastructure as code is sort of the piece that that we're targeting first, because when you look at where the pain comes in from how we approach automation generally, infrastructure as code is like number one with a bullet in terms of where the end user problem lives.
Yeah, absolutely. And I'll kind of add another one to that as well. So in researching for this, one thing I noticed though with your site in particular is, everything is extremely visual and it has a nice UI and you're kind of building out models, if you will, right? And digital twins and some of these other things, right? And it's funny too, because like I feel like, in the early days of DevOps and then the infrastructure as code days, like everything's APIs, everything's command lines. And so like I would go to these conferences and it's like, all right, let me show you the demo. And then you'd pull up a command line and me, right. I have two things about this podcast, learn about me. I like Vim and I'm a visual learner. And I immediately my eyes kind of glaze over.
I get it.
And
I
so
do.
like, is that intentional too? Or is that just like the best way? Like, okay, if you're building out models, is this the best way to build out models? Right.
Yeah. It's more the latter. So like, I helped to build the fundamental technology that sort of inspired a lot of what's happening in infrastructure as code. Like I've been a lifelong believer that that's the way that you should interact with these systems. And, one of the most surprising things about building System Initiative is that it turns out that once what you have is this programmable model, that you can build all kinds of new ways to interact with the model that are really powerful and that then also enable you to write code. So for example, the living architecture diagram that you use to compose things in System Initiative, it's just a lot easier to build relationships between cloud resources by drawing a line than it is by like remembering what the name of the resource type was and then putting a dot and then the thing after it. Like, it's not that you couldn't do it the other way, and LSP helps you, but like, it's pretty great and pretty quick to sort of work that way. Now, under the hood, it's writing code for you in the same way that when you interact with a model in Unity, right? Nobody would look at the 3D modeler in Unity and be like, that doesn't generate code. Like, obviously it does, right? Obviously, in the end, it's running code, but you don't interact with the code for the model for the most part, right? You use the 3D modeler they give you. Another example in System Initiative is, you can mount the entirety of your System Initiative workspace as a file system and just interact with that. And it's doing the exact same thing that happens when you're using the UI. And those things are possible because what you have is this underlying model of how automation behaves and how the system works that allow you to build these different user interfaces. And so it's less about saying, hey, we shouldn't have to write code, because that's a lie. Like, especially as the complexity increases, you absolutely need to be able to write code. And if you can't, then the system won't work, right? It won't scale to the needs to what you need it to be. And you should be able to provide different interfaces for different people and for the different jobs that they decide to do. And that's one of the key things you get by having this model at the core instead of just talking about it as source code.
Yeah, that's perfect. Thank you. And let's also talk about this, because we kind of talked about it like, okay, you're building models and you're certainly, abstracting away some of the complexity, but that's immediately where my mind goes to whenever I think of DevOps and infrastructure as code in the past, is like complexity and dependencies.
Yeah.
I feel like those are like the bane of developers' existence when it comes to building some of these things sometimes. And so how should folks today, consider this, and what kind of advances have we made? Is it just simply better and better abstraction, and then it goes and figures it out, or how should people think about that now?
It's so counterintuitive. So it turns out that it's very seductive to believe that there's an abstraction that is what you should be interacting with. The truth is, what you need is to have a very high fidelity model of reality, and then you need to be able to build also high fidelity models of the semantics you want to deal with. So here's an example. Like, let's say that you deploy applications to Amazon's Elastic Container Service, right? And so you have a standardized way probably that you build those clusters, that you think about the networking layers, load balancers, all that stuff. So experts can build that stuff in System Initiative. Then we can turn that into a reusable template that then is itself a model that you drop on the canvas, and you fill in, some properties that are like, hey, what's the container you want to deploy or whatever it is. And then you can just run that as a function, which then will then create all the infrastructure for you and manage it over time. And so if I'm an application developer, I want to interact with that high level component. I just want to talk about my app. I want to talk about deployment. I want to talk about it in terms of, releases, whatever it is I want to say. And you got to be able to model that semantic and then have it drive these high fidelity models under the hood. Because it's great to have an abstraction until what I need is the abstraction to be a little different. And when it needs to be a little different, then we get this, what I call the 200% problem, where I have to understand like everything about the underlying system and everything about how you abstracted it in order to try to figure out how to make it do what I want. And so we kind of eliminate that problem by just letting you manipulate all of these really high fidelity underlying components. And it works fantastically well. I think the where we're at as an industry is it's just early days in realizing that you could do better than the way that we do automation today, because we've been doing it this way since the middle 90s. So, it takes a minute to get out into the world and be like, hey, like this, there's a better way to do this. Here's a way to think about this problem that unlocks all this crazy potential. And that's where we are right now as an industry. I think what you're seeing not just at System Initiative, but in other startups as well, is that there's kind of a raft of people who are thinking about this problem now because it's clear that the current course and speed doesn't get you home.
Yeah, yeah. And let me kind of add a follow on to that as well. We're kind of talking about state of the industry as well. How does like the I don't know if it's even an evolution. I guess maybe I'll ask it. Is there an evolution in open source? And what is your thoughts on like, okay, open source back in Chef days versus open source today? And like you see more and more like changing of licenses over time.
Yeah.
And like, and then that's potentially impacting like just the impression of it at times. And so like, where are you at with that? Right?
Yeah. I mean, so System Initiative is completely open source. All of it is under the Apache license. And I think in general, where we're at, I think, is that over, I think it's hard to think about open source alone. So, open source itself is basically an embracing of open development models. And it kind of borrows the philosophical underpinnings of free software. And free software is about this idea that like software by its nature is infinite. And therefore, when I share it with you, it doesn't take anything away from me, right? And because of that, we can change the way we relate to software, right? If the software is open and free, then the software can serve us instead of us serving the software, which is what happens when we have like limited resources in the world, right? Like we're all kind of a slave to our ability to gather resources, right? If the resources are infinite, then this is no longer a problem. That's the sort of philosophical underpinning of free software. And open source kind of inherits it, right? But it shifts the focus toward open development models. It says what really is great isn't this like highfalutin philosophical Star Trek thing, but instead just the fact that we can work together, that we can collaborate is what's good. And it makes it a little more palatable conceptually to business because it's not about, upending the core foundations of the economic regime that has created, modern life. And so the unfortunate side effect is that now we're far enough into the game and, venture capital and all this stuff has come into it. And most people have forgotten. Open source has been so successful that most people don't even actually know what it is, much less remember its connections to some philosophical principle about the nature of software, right? Most people are just like, it's on GitHub. That makes it open source. I'm done, right? And so what we're seeing is a couple of things. There's a lack of sophistication in entrepreneurs about how to construct a business model that uses open source and how that interacts at a business level. So like, how does it impact how I treat competition? How does it impact what I sell? How does it impact how I price and package my software? Like all of those things are things that open source has an impact to, and we're just not very sophisticated. And instead what we do is sort of listen to random people's greatest hits. We're like, well, the HashiCorp guys were successful and they changed their license, so maybe we should change our license. Or or whatever we're doing. From an actual business perspective, if you start to break it down, we've sort of chosen the least efficient business model, which is kind of open core. This idea that I like open source my software and then I build some kind of enterprise edition around it, and I try to sell that for money. It drives the price down. It's not very efficient. And it does over time, if you're successful, cause the circumstances that lead to people changing their licenses. Because as you get saturation in the market, it becomes harder to just figure out like who's left to sell it to, right? There's a bunch of people who are happy not being sold. I don't know how to get access to those people. The average selling price is low, becomes a bummer. So I think as an industry, we're having this moment of reckoning where the inefficiency in that business model for the people who are successful is causing, and the lack of understanding in terms of consumers and entrepreneurs about what the actual foundational moral and ethical principles are behind why we're doing this in the first place has been lost. That it kind of leads you towards saying, well, what if it was just open-ish? What if I didn't actually care too much about the open development model anyway? What if I mostly just cared that you could see the source code on GitHub? Was that good enough? Because if it was, then I'll just keep all the money for myself, right? And wouldn't that be easier and more straightforward? And, the answer is yes on some vector. And
sure.
but also no when it comes down to actually creating software that forms huge communities and a movement of people who are using that software to better their lives. Like, you know, it's not the same thing for you to say to me, like, hey, you can look at the source code of Excel. I don't care, right? I'm a consumer in the end of Excel. But if Excel was open source, that would be different. You know, like suddenly it would matter that I could use Excel to, you know, to create whatever I needed in the world. That would be fabulous. And so we're kind of in this moment where I think mostly consumers have forgotten why they care, and engineers have forgotten why they care. And so we're a little stuck. And my hope is that I'm trying to fix it from a business model point of view, where I stop talking so much about the open source part and just start explaining to people how their business models work, and saying, you know, there's a great open source business model that is selling your product for money and using your trademark and distribution licenses and making that happen. People should use it more often. There's a very inefficient one that's been very popular for a long time, which is open core. You could do that. We know how it ends if you're successful. But, you know, that's where we're at, I think. I think we're a little stuck.
No, it makes sense. It makes sense. And I think to your point, like, things are in a bit of a state of transition, both from perception versus reality, but also to where we're going, you know, as an industry. So it makes sense. And so we'll have to talk about it again, you know, in a little while as well. So let me ask you this. Let's talk about like metrics for success, if you will, right? Like, so if I think about DevOps, like back in the day, it used to be like, hey, number of code commits, or if it's infrastructure as code, it was like, oh, how many seamless deployments and actions are you doing in a given amount of time? And have those kind of metrics changed as we're kind of moving on from infrastructure as code, or is that still like, is it like, how do you look at it now that it's more like platforms and tools? Right?
I mean, it's funny, right? So one of the reasons that we're de-emphasizing those metrics is because they suck. Not because the metric's bad, but because when we actually objectively look at them, we're like, ugh, we never do a good job. You can see this in like the DORA report, where, you know, when it talks about our aspirations to DevOps, you know, we wanted to be able to deploy on demand safely, you know, at large scale. The number of teams who can do that is minuscule. You know, the vast majority cannot come anywhere close. And so we've called high performers people who can deploy once a week, right? If you can deploy once a week, you're a high performer now. And that is an incredible reduction in, you know, in what we mean when we talk about high performance. And it's because the systems we've been building don't actually support you in getting to high performance. It's possible, but it is fraught with peril. And so we've sort of de-emphasized some of those metrics over time because they're bad. And people don't like looking at them. And so we recontextualize them in ways that are like, well, what we said was actually low performance is now good performance because everybody's a low performer. So, you know, we don't want to just say everybody sucks. Like, that's not very good for us as an industry, you know?
Sure.
I think part of what we're starting to see is, you know, being able to talk about deployment frequency and success. Like, I actually still think that's a pretty solid metric. And not because driving deployment frequency up is always the right move. So, you know, that's why success is an important piece of it, because deployments for no reason, obviously not useful, right? So if I have a stable system that's been stable for a decade and it doesn't need to be deployed every day, obviously it's not better to deploy it every day. That's just churn for nothing, right? But if you think about it in terms of, what is the developer safety? What's the, you know, how can I trust that if I need to do something, I know that lever will work. I know that it's going to function the way I expect it to. I think that's probably the metric we should be thinking about and looking at, because it's less tied to just pure frequency and more about the developer experience and the safety of, well, can I trust the system to do what I need it to do when I need it to do it? And, you know, at whatever frequency that needs to be. And for most people, the answer to that question is no, right? Like, it fails them on some level or another, you know, and does so regularly. And so when you think about that shift toward platforms, all those things, it's all an attempt to figure out, like, how do we give someone a better mechanism, better interface? And, you know, one struggle with the current trajectory of like platform engineering is that it's largely built on the foundations of historic automation principles. And so it turns out that if the underpinnings of the automation drive these outcomes, then putting a platform on top of it does not improve the outcomes. Yeah. because it can't, because the actual underlying technology is what's driving the behavior. So, it's
Sure.
not that the semantics aren't better. It's not that it's not nicer to like maybe go to a portal and be like, I want to deploy some stuff. That could be cool. How am I going to feel about it all up though? Roughly the way I felt about it when I did it by hand. Roughly the way I felt about it when I did it with infrastructure as code, because that's in the end what I'm doing. And so if we want it to be better, you have to change that fundamental primitive somehow. And mostly we're not.
Yeah, that makes sense. No, that's perfect. Thank you. So, final topic before we close out here. I want to talk about AI a little bit, because as I was kind of thinking through all of this, like I kind of feel like there's a bunch of ways AI could help, and I'm going to use air quotes around help there,
Totally.
just like you did earlier. Like there's summarization of large amounts of data, or trying to figure out where the heck we are. There's digital twins and simulations. There's agentic AI actually performing tasks based on conditions. Like, what is your thoughts on where AI is appropriate for all of this going forward?
Yeah, I think one of the mistakes we've made sort of as technologists around AI is sort of failing to look at it as technology, because it does feel kind of magical, because it's this new capability that sort of didn't exist before. And so we all kind of reacted as if it was this mysterious thing we couldn't understand. And I think, ultimately today, what it's really good at is if you have data in one shape and you want to transform it into another shape, there's never been a better time to exist. Like LLMs do that incredibly well. Do you have words you want to turn into a picture? We got you. Do you have a video you want to turn into words? I got you. Do you have, some source code you want to change to a different shape of source code? I got you. Like it's really good at that shape of a problem. It's like a crazy regular expression machine on steroids, with a really annoying programming interface. I think when you look at how that can apply though, there's a lot of places where once you have a model that's more clear, that it starts to become obvious. So like, for example, data transformation. I mean, if I have all the data and it's in multiple places, it makes a lot of sense that I could ask a system to translate it from one thing to another, right? And that the translation will likely be very high quality, because I can tell it exactly what the shape is on both sides. And so I can say, hey, I have information about this database that's running on this service. I want you to give me the equivalent size running in Azure. And the odds that you can ask that question of a system that has a model of both AWS and Azure and be pleased with the results, pretty high, right? Then there's the question of like, agentic systems or interacting with you, in some particular way. Another advantage of having these models is that the models themselves can be multiplayer. So like right now, if you go to System Initiative and we both log into the same workspace, we see each other's cursors. And like when you do things in the change set, I see it happen in real time in my browser, right? And there's no reason that has to be a person, right? It obviously could be a robot that you're asking to do work on your behalf, and then you could watch that thing do work, which is one of the things that's most complicated when you think about how do I build like an AI system that thinks about doing operations. I think the biggest struggle with AI is actually just going to be that bridge from I can do good data transformation to I can make good decisions about the data. Ooh. Like that part, I think we're still a little ways off without some new technology or some new approaches, which doesn't mean we won't get there. Lots of money pouring into the space, plenty of people trying to solve this problem. I wouldn't necessarily bet against it, but I think today, with the status quo of that technology, you can be pretty sure that you're unlikely to see systems that are looking at complex infrastructure or application deployment problems or any of those sorts of really complicated large-scale issues and having AI make any useful decisions. Because in order to make a useful decision, we would need to feed it better data. And I think the promise initially was just, well, we're just going to throw all the data at the God machine, and then the God machine was going to sort it out. And like, I think we're kind of learning that that's bullshit, that like there's a bit of garbage in, garbage out here. And especially when we're talking about control systems, not summarization, not other tasks, but like control systems, that I'm not seeing emergent control systems like at all. And I don't think we will without like real advancement in the technology, which may happen, but today, not a thing.
Yeah, fair. I think that's also too a really adequate assessment of just the AI industry as a whole, because there is a lot of shiny objects, and then there's a lot of great demos, and then when it comes to really getting that ROI on it and getting to actually, okay, hey, I wanted to actually do stuff, or do stuff in a way that I wanted to do things. It
A little tougher.
becomes a very mixed bag. Very mixed bag, right?
Yeah, it's definitely a mixed bag. And when you look at the places where it's having the most success, right? Like I've sat with people who are using Cursor to write code, and they're like having a good time using Cursor, and Cursor's doing quite a bit of work for them. Amazing, great. That's a long way from an autonomous control system that's figuring out how to deploy your application on demand based on an analysis of pure data, and then deciding that what you want to do is let it create and destroy things in the real world at random. Like, a long way. Like if you look at how many edits you need to make and what that loop looks like and how tight they make it, they're not usually asking it to do big, long tasks. They're asking it to do shorter, more bespoke ones that they already understand the context of, like there's a flow here. And I think that when you think about AI and infrastructure and automation in general, that's the thing you should be thinking about is like, okay, how can I use this thing to make the feedback loops better? Like we use AI to read the CloudFormation specifications. They're not complete. The documentation actually has more specification than just the specification itself has in terms of like valid values and enums and all kinds of stuff. So we use AI to read the documentation and extract validation. Incredible. So cool, right? But you never see it, right? You just see the validation.
That makes sense. No, I think that's great. And I think that actually that's a good spot actually to pause for today. So Adam, very much thank you for your time. I really appreciate a great conversation as always. And for everyone out there, thank you very much for listening. Wanted to also tell everyone, if you have feedback, send us an email, show@thecloudcast.net. And on behalf of Brian and myself, if you enjoy the show, please, wherever you get your podcast, leave us a review if possible, and also tell a friend. And so on behalf of Brian and myself for this week, we certainly thank you for your time, and we will talk to everyone next week.
Bye.